Hello, ladies and gentlemen. This is Mr. Black, and I'm going to be working with you today again, developing another iOS app using the programming language of Swift 2.2 and XCode. And what we're going to be developing today is solving linear systems and teaching Swift and XCode how to manipulate equations and how to come out with a solution to a linear system. So one of the things I've always found is that as a math teacher, if I can teach students how to computer program solutions to math problems by following a sequence of steps, students will never forget the system of steps. In my class, they're actually allowed to use any program that they've developed on a test or on an assignment, and most of the time those students no longer need the app that they've developed because they now understand the greater meaning of the steps that are involved in solving a mathematical equation. So today I'm going to be working with you, and you might remember that in grade 10 you probably learned how to solve a linear system, which means to try to find a point of intersection between two lines in several different ways. There are typically two ways that we look at. One is called substitution, and that means that usually you try to solve one of the equations for a single variable with no leading coefficients, no numbers attached to it, and that number 1 that is actually hidden in front of it is a positive 1. And then we take that y value and we set it equal to the other equation, which makes it fairly easy to try to solve for the other variables. And the other way is called elimination. There are several different steps to elimination depending on how easy the equations are when they're set up for you. So for starters, I'm just going to quickly review some of these, and then we'll step forward and try to develop a solution for teaching a computer how to do this on its own. So the first thing that we're going to do is we're just going to take a look very briefly at substitution. And the easiest way to deal with substitution is when we have two equations that are explicitly defined by one variable. And what I mean by that is it says y equals with nothing else attached to the y. So if that is the case for both of those equations, we can then set all of the other stuff equal to each other, because if we assume that y is equal to y, then it means all of this other stuff has to be equal to each other as well. And when we solve this system of equations using substitution, we can just use algebra to manipulate the equations by pulling terms from one side of the equation to the other, and all of the constant values, the numbers, to the other side of the equation to set it up very nicely. So I would have 3x minus 2x when the 2x gets moved to the other side is equal to negative 1, which is staying on the right-hand side, and I'm going to move the negative 4 to the other side, which will make it positive 4. When I tie these two together by combining the like terms, I will get 1x is equal to negative 1 plus 4 is positive 3. So x is equal to 3, and then I can now substitute that value of x equal to 3 into either one of these two equations to solve for the y value. And it really doesn't matter which equation that I substitute that number into, because the y value will be the same, because what we're looking for is a point of intersection. The point of intersection will be shared between both of these lines. And these lines are obviously in the form y equals mx plus b to begin with. But what happens when things are not set up nicely for you, when things are set up not in the form y equals mx plus b? Well, oftentimes we will try to use a strategy called elimination to eliminate one of the variables, to focus just on either x or y, and then to solve for that variable. Once we solve for one variable, we can use that same strategy to plug it back into either equation to solve for the other variable. So the easy way that we use elimination is if we can identify that we have opposite variables or opposite terms to begin with. So if I look quickly at my x term, I have 2x and negative 1x. Those are definitely not opposite variables. But I look at my y term for each equation, and I have negative 3y and positive 3y. The numbers and the coefficients are the same, 3 and 3, but the signs are opposite, and that's what makes these opposite terms. And when we have opposite terms, it's really easy to add these two equations vertically to try to come out with a solution. Because if I add opposite variables, they will be eliminated. So I would have 2x plus negative 1x, which will give me 1x. These two will add up to 0y, which means it's eliminated, and these two numbers will equal 6. So on the next step of the equation, I would have 1x is equal to 6, and I'm halfway done. All I need to do is now solve for y, and I can do that by plugging 6 into either equation for x, and then work through the problem using algebra to solve for the y variable. Moving on to a more difficult one. In this case, what you'll notice is that we don't have opposite variables. So the way that we handle this problem, and you've probably been taught this method at some point, is that we multiply one of the equations by a single number to create that opposite. Now there are many different ways to deal with this, and each teacher probably has their own sort of special technique. But what I found is that if you can create opposite variables, one that's positive and one that's negative, and yet they have the same coefficient, it's the easiest way because all we have to do is add the two equations together and the answer will essentially pop out. Now, that doesn't happen right away here. I see that I have 2x and negative 1x, definitely not opposites, and neither are my y variables. So I'm going to have to choose a number to multiply by one of these two equations to create an opposite. My focus right now is on this little guy right here, negative x. If I was to multiply negative x by 2, then that would create the opposite variable. Well, hold on. Am I just allowed to start multiplying single terms inside of an equation by any number that I really want? Absolutely not. But you might remember that one of the rules of algebra states that whatever I do to one side, I have to do to the other. So what I'm going to do is I'm going to multiply equation 2 by 2. And if I do that to all of the terms on one side and the other side, that equation, although it might look different, will be exactly the same. What I will get for this is negative 2x, 2y times 2 is 4y, and 1 times 2 is 2. Now I've created my opposites. I can use the same strategy up here, and I can add these together and eventually solve for my variables. I'm not going to do that right now, but you could probably work through the problem on your own if you really felt like it. And then the last type of linear system where we're going to be using elimination to solve, the hard one, is when we don't have this option of just multiplying one of the equations by a number and having an opposite suddenly pop out like it happened in this equation right here. So what we have to do is we have to multiply both equations by a single number and then try to create an opposite between them. For instance, if I was to multiply equation 1 by 3 and also down here multiply equation 2 by 2, what will happen is I will get 6x and negative 6x, which creates the opposite variables between them, and as long as I multiply all of the other terms by the respective number, then things will work out nicely. Now, your teachers have probably never told you about another option that works for all of these cases. What that option says is that even in the very hard cases, I am allowed to multiply only one of the equations by a specific number. Well, where do I get that number from? I get that number from the leading coefficients set up as a fraction. Now that means you're going to be multiplying everything in one of the equations by a fraction, and this is exactly why your teacher never taught you this principle. But this is the way that we're going to be teaching the computer. It's the easiest and it's going to take the fewest steps in order to try to build an algorithm, a set of steps to teach the computer how to solve a linear system. So in this case, what I would do is I would multiply equation 2 by the leading coefficient of 1 as the numerator, so that would be 2, divided by the leading coefficient of our other term right here. So in this case, I would be multiplying equation 2 by 2/3. Wow, that's a little bit tricky. What happens when you multiply -3 by 2/3? Well, -3 multiplied by 2 is -6, and divided by 3 is -2. And that would actually create right here an opposite variable to begin with. And that opposite variable then can be used on all of the other respective terms by still multiplying by this number, and then the same solutions will eventually pop out. So we're going to be using this strategy here today to teach Swift and XCode how to solve a linear system. So for starters, we're going to build a single view application. Again, the reason why we typically choose this is it has the least amount of code to start with, and most of the code we're going to be coming up with from scratch. I'm just going to call this guy the solving linear systems. I'll keep everything else the same. I might choose to switch to an iPhone this time just to keep things a little bit more condensed. It's totally up to you which one you want to be working with. And I'm just going to keep this on my desktop. And there we go. Okay, so to begin with, the first thing we're going to be doing is we're going to be constructing the main storyboard. And remember that the storyboard is the interface where you place all of the controls that someone will be using on their iPhone or their iPad. All of the controls and the objects that we can place are usually down here. So the ones that I'm going to be working with today, there are going to be quite a few. So what I'll do is I'm going to build the interface for this, and I'll go through any of the ones that might be a little bit confusing right after. All right, so what I've done is I've created the interface that we're going to be using for the Linear System Solver app. And I'll just go through very quickly with you what you're looking at right now so that you can develop this on your own. So the first thing I've got is that anyone that's using this app must list their equations in the form ax plus by equals c. And you can see the format down here. So what I've got are several labels just for listing. So this is an equation 1 that's a label. This is a label. The x plus here, the y equals are all labels. These are your text fields. That's where people will be entering in their information inside the app. So this is a text field for x, for y, for the c value, which just represents the constant value, the x value, the second equation y value, and also the c value down here. This right here is a button that someone will push when they are ready to solve their linear system after they've placed all of the input into the appropriate fields. The last thing right here, this one might be a little bit tricky, is a big label that I've just created 20 lines and then just extended the format so that we're going to be printing our solution. When we print our solution, we're going to be adding on to the text that's already displayed and truncating it onto the end of it. And that's pretty much it. So the next thing that we have to do, I'm just going to collapse this guy on the left-hand side so that I can bring up my code connected to the interface. So I've got my storyboard on the left-hand side, and I have my code here on the right-hand side for the view controller. So this view controller right here, this UI view controller, is currently as the default set up with this view controller, which can be found right here inside your listing of all your files that you're using. So if you remember from last time, the first thing that we have to do is we have to make connections with all of the objects that we're going to be referring to from our storyboard into our view controller class, this guy right here. So I'm going to right click and I'm going to drag from the left hand side to the right hand side, and I'm going to be making outlets for all of the text fields. Those will create variables that I can refer to in my code, that I can grab information from them, I can change information from them, and I can even deal with all of the properties over here if I really felt like doing that. We're not going to do that today, but that's an option for later on. So the first one I'm going to do is I'm going to call this guy right here my equation 1 x value. And I'm going to keep everything else the same, and I'm going to make sure that it's an outlet. So I'm going to be creating all of these right at the top of my class, but I'm just making sure that I'm inside the class itself. This guy right here will be called equation 1y. This guy right here will be called equation 1c. Continuing to move forward, I'm going to have equation 2x. Oops. This will be equation 2y. And equation 2c. I'll just that. So now I've got my 6 different text fields as variables that are connected. So as I make changes here, I can actually reference those changes inside each one of the names that I've currently got. The next thing I need to do is I need to create a function for an action that happens. So when someone clicks on this button right here, they're basically specifying that they are going to be ready to solve the linear system. So I'm going to turn this from an outlet into an action. I'm going to leave the event as the touch up inside because that's when someone presses a button on an iOS device. And I'm going to say, I'm going to give the name of this maybe solve clicked. And it creates a function for me. And all of the code that we're going to be working with, or most of the code, is going to be placed inside this area right here. So how do I deal with this? What am I going to be doing? Well, the first thing I'm going to be doing is I'm going to be grabbing all of my information from the text fields, which are referenced by these variables. I'm going to be storing those inside variables. The one thing I'm going to be dealing with is that this app can work for integer values, whole numbers, both positive and negative, but we also want to give the option that if someone was to put in a decimal number, that this linear system solver will actually work for all of those values. To begin with, we are going to create new variables. Now you'll notice by the let statement that I'm starting with that these are constant variables, and I am going to force these variables to hold a float. And what I want to do is I want to grab the information from that text field that we have right here. So the first one will be equation 1x, and what I want to get from that is the text property. Now, there's going to be a problem when I do this. Swift is going to say that, well, hold on. The information that we get from a text field is classed as a string. In other words, the text property is a string. And what you're trying to do is you're trying to place this into a variable that is a float, and those two things are different types. So what I need to do is I need to convert the string value from here into a float so that I can properly store it inside this variable. How do I do that? Well, there is one way that we can do like so. This is called casting, where we are converting one type of variable and forcing it to be another type of variable. And the other error, I'm guessing, is probably something to do with an optional value. Yes. So when we get something from a text field, it's quite possible that the stuff that's inside of here is actually empty. And if things are left empty inside of here, that means their value is nil. So this right here has the option to hold a value or to be nil, and that's what the definition of an optional is. So whenever we're trying to use an optional value, we have to unwrap it, and we do so using the exclamation mark. Oh, sorry. And the last thing is that we need to also unwrap the float must also be an optional value. All right, so the little error right now is that this is saying that you've created this variable using a let, but you never actually use it through the rest of the program. We will be using it later on, so this little warning message will disappear. Now, we can use this over and over and over again to grab all of our information from our text fields, convert those to a float, and then store those into a float as well. That's quite a bit of work to do for just one little thing. So what's going to happen is we're going to be doing this 6 times, and that usually indicates that if you're doing something very repetitive in code, that you should be building a function in order to do all of this stuff at once. Inside this function, you can actually add a little bit of safety as well. So what would happen if someone typed the letter A into a text field? Would that actually crash a program? What might happen if they put some really weird input in there? So we're going to add some little safety features to make sure that if they do put a letter A in here, that we can give them an alert and basically say, please enter us good valid input before I do any of the calculations. If we try to do mathematical calculations with invalid input, it's probably going to crash the program, and that's the last thing that you want. So we are going to develop a little function. So I'm going to place this just underneath the 2 pre-built functions that you'll notice are automatically given to us when we create the view controller for the first time. The function that I'm going to create, I'm going to name it change to float. And the change to float function is going to accept one parameter. I'm going to give the name of this parameter number to change, and it's going to be a string value. And the reason why it's going to be a string value is because we're getting it from a text field, and the text from a text field is a string value. So the last thing I'm going to be doing is I'm going to be returning a value back. So once we take this number to change, convert it from a string into a float, we will then return a float value. And this is the syntax for creating a function that returns a value, and in this case I'm returning one value, which is a float. This is going to also give us the option to do a little bit of error checking just to make sure, like we said before, that all of the valid input is actually valid, that a user indicates to us when or right before they press the solve linear system button. You've probably seen this before in some of the Swift tutorials that you worked through before, and it's called an if-let statement. And I'm going to say if let num equals float, so I'm casting the number to change from the string to a float, very similar to what we did up here. And we do this if let. And what that basically says is that if I can change this from the string to a float, then we're all good. That's actually a really good thing. But what happens if I can't change it? Like if I had the letter A, I can't make a float, a decimal number, out of that letter, then that's where the else clause is going to come as a part of our if-else statement. So I'll set both of those pieces up right now. So the first part of the clause, what I'm going to do is I'm going to print a little message to my console, and this is the format or the syntax for creating that, and I'm just going to say this is the number that I'm converting. And that way I can see what's going on inside my input, and these are just messages for myself. And please remember that your console is actually hidden inside this guy right here. So we'll print messages to ourselves throughout this program just to see what's going on. It's more for error checking, just to see if things are actually working the way they're supposed to be working. We're also going to be using string interpolation, and that means that I can write different variables inside a string. So the string goes from here to here, even though they're different types. So even though the num will be a float, I can place that num using this notation right here with a slash inside parentheses, and it will print out the appropriate number. Once I've done that, then all I have to do is just return the number once it has been converted, and the num will be a float at this point, and it will return back to the value. And the other thing that we're going to do is we're going to print another message right here, and that message is going to say there was an error converting the value to a float. And then I'm also going to use string interpolation this time to state what that value was. The value in this case would be number to change, which is also another string. And then I'm required to return a float value. So I'm just going to put in the default of 0, 0. You have to return something. So what I'm going to choose to return back when the function gets called is just 0. So anytime something bad happens and someone inputs improper or invalid input, we are going to be returning 0 back to the top. And you'll see why we do that a little bit later. So how do I actually use this? Well, I'm going to be taking away the conversion that happens here, and we're going to let our function do all of the converting. And to do that, what we're going to say is the name of the function, change to float. Now, change to float requires a string to convert to a number, to a decimal number, which is called a float. And what we're going to be converting is equation1 dot text. I have to unwrap it before I send it back, and that should all be good. All right, so this basically just says, okay, I've got this guy, this variable created that's going to convert my text field from the string into a float. Now I'm going to be using this idea again and again and again and again for my y1, my c1, my x2, my y2, and my c2. Right, and that represents all of these, x1, y1, c1, x2, y2, c2. I then have to pass the appropriate values in, so this would be equation 1y, this one would be equation 1c, this would be equation 2x, equation 2y, and finally equation 2c. All right, so each one of these now uses our function to properly convert the string into the float. And again, these little warning messages off to the side are saying you created these variables, but you haven't used them yet. And we're about to start using those. Now, before we do that, we just want to make one thing clear. Let's suppose that something bad did happen, that there was invalid input. Then any of the calculations are going to fall apart when I try to do them. So what we're going to do is we're going to create a variable, a global variable, which means it has to be at the very top, just inside the class. In other words, it's not built inside a function, any of these guys that are pre-built. And the name of the variable I'm going to give is going to be my numbers are a-okay. And I'm going to create a Boolean variable which has only one of two values. Either it's true or it's false. And the Boolean value I'm going to set is I'm going to assume that all of the numbers are a-okay that are entered in here. But I'm only going to change this variable to false if there's bad input. And remember, that's what this guy handled down here. So right after I print my error message, I'm going to say numbers are a-okay is actually false. In other words, my numbers aren't okay. There's something bad with that. And what that allows us to do is that afterwards, after we get all of these values, and even if there was a bad value, remember that what's going to be stored inside of here is going to be the number 0 because that's what was returned. But if there is a bad value, then this little variable right here is going to tell me, it's going to keep track of that bad value. So I can say, if my numbers are a-okay, then I'm going to do a bunch of stuff. And in fact, we're going to do a lot of stuff. Or else, we can do something else. All right, and we're going to just create a little pop-up that happens. It's called an alert, and it just gets presented to the user. None of the calculations will happen because all of the calculations will be in the if part of the conditional statement. So let's jump back here and let's actually start writing the code. So as I explained at the start, how do we do this? Well, we have to create a fraction that we're going to be multiplying by only one of the equations. The fraction is built from the coefficients, the numbers that are attached to the x variables right here. You could easily do this for your y variables as well. There are a couple things that I'm missing inside of here as well, like what would happen if one of those values was 0. You can't actually divide by 0, but we're going to assume that most of this stuff is okay, and we can make tweaks later on just to solidify this and make it quite a bit more safe. But for our purposes, we're going to keep things as simple as possible right now. So the first thing we're going to do is we have to check the sign. We got to make sure that if we're trying to create an opposite variable, that the signs need to be different from one another. Well, how do you make sure that the signs are different from one another? Well, we're going to create another function, and this function's job is to make sure that the sign is the same. So to create another function, I'll just put it down here with the change to float function, and I'll call it, let's say, check sign. And again, we'll just build the basic syntax for a function. So this function's name is check sign. Now we're going to be accepting 2 parameters for this function, 2 numbers. And we're going to compare the signs of those 2 numbers. So the first one is going to be a float, which we've just created all of those floats up top. The second one is also going to be a float. And after I compare the signs, we are going to return a Boolean value. The bool means we have to return either true or false. So we're going to compare the sign of this one with this one, and if they are the same sign, we will return true. If they're different signs, we will return false. So what I'm going to say is if number 1 is greater than 0, and number 2 is also greater than 0, then that tells me those 2 numbers have the same sign. They're both positive values. And what I will do is I will say return true, which is a Boolean value. Now, there's one other condition that I have to check here as well. What would happen if number 1 was negative and number 2 is negative? So I'm going to create an OR portion of this by using the 2 vertical lines right above your return key, and I'm going to say if number 1 is less than 0 and number 2 is less than 0 as well. So if these 2 numbers are either positive or they're negative, then we will return true. Otherwise, we will return false. And it's really important that we know that the signs are the same as we work through this. Oops, okay. So what this is saying is that I have a unresolved identifier, basically saying you got a variable that you're using but you never built it, and I just made a mistake by forgetting to add the number 2 up here. And that should disappear. So now we have if the numbers are positive or the numbers are negative, that means they're the same and we will return true. Otherwise, we will return false. And now we're going to start by using that function to check the signs. I'm going to create a variable, a constant variable called sign is same. Sign is the same. And what we're going to do is we're going to use our function that we just built. Now you'll notice that as I start typing check sign, which is the name of that function right here, it's actually telling me that it requires 2 parameters. And the parameters that I place inside of this are going to be x1. So I'm checking the x1 variable here with the x2 variable just to see if they have the same sign, if they're both positive or they're both negative. And x2. And I will either get a true or a false returned if they're the same sign. And that will be stored inside this variable that we're going to be getting later on. Now this part is the tricky part. The fraction that we are going to be making requires a few different pieces. We need a sign that we might have to change. For instance, if one said 2x, we want the other one to say negative 2x, so we might have to multiply it by negative 1. So we're going to create a variable, and this time this variable might change, so we need to create it as a var, not a let, so it can't be a constant because it might change. And I'm going to create this as a float because we're going to be multiplying with a bunch of other floats, so it needs to be the same type. And the sign multiplier, I'm just making 1. In other words, I'm just creating positive 1 that I'm going to be multiplying. But then what I'm going to do is I'm going to check my sign if it's the same, and if the sign is not the same, that's what this statement here, that little exclamation mark means not. So if the sign is not the same based on the check sign function that was returned, then my sign multiplier is going to equal negative 1.0, a float value. All right, so we now have the appropriate sign to multiply by one of these two values. And now what we're going to be doing is we are going to be multiplying equation number 2 by the sign. That's the sign multiplier that we just created. And we're going to multiply that by the leading coefficient of equation number 1, and then we're going to be dividing that by the leading coefficient of equation number 2. Yikes. What this little statement is doing is it's just telling me that the fraction that I need to create to multiply by all of these guys, and if you remember back to this one, we ended up multiplying this whole equation by 2/3. Where did I get the 2/3? I took this as my numerator, this is my denominator, and then I just have to play around with the sign to make sure they're opposites. If they're already opposites, I don't want to turn that, and if they are both the same, then I need to make one of those a negative. So all I'm doing is I'm creating a fraction with this as my numerator, and this is my denominator. And that's what this little statement is essentially saying. So what I have to do now is I'm going to create a multiplier. So this multiplier is going to be equal to whatever this statement right here says. So the multiplier is going to be the sign multiplier that we just created. Either it's positive 1 or it's negative 1. That's just multiplying by the sign. And I'm going to be multiplying that by x1 and then dividing by x2. And that right there is the fraction of the coefficients, the x value divided by this x value. The next thing we're going to do is we are going to start building this statement right down here. All right, so we're going to start building the solution step by step, what is actually happening as I'm going through my code. We can also start printing error messages to ourselves just in case something bad happens. So let's actually get the solution set up because we actually have never created the connection. So what I'll do is I will create this right here again at the very top, and I'm going to create an outlet so that it's a variable that we can use, and I'll just call it label output. And that means now I can use it and all of its properties as a part of my code. I'm also going to just get rid of this. We don't really need that window open anymore. And all right, so let's keep moving along. At this point right now, there are no bugs that I'm noticing. There are a couple different warnings, and again, most of these warnings are just saying that you've created all of these variables, you're not using them, so you better start using them, otherwise you might as well just delete them. But I'm going to play the program right now, and as we run the app, what we'll try to do is we'll just try to throw in some values and just see what is actually being outputted here. So I'm going to just type in maybe 1, 2, 3, 4, 5, and 6. When I press that Solve Linear System button, what my focus is on right now is that we printed error messages to ourselves. We said, this is the number that I'm converting. Now, that means, if you think back to the change to float function that we created, that this value right here was able to be converted if I was able to print this line. So I was able to change the string value that we were entered. I was able to change 1 from a string into a float, and then now I'm going to be using the floats up here inside my calculations. Let's try to run it again, only this time what we'll do is I'll put something like A 2, 3, 4, 5, and 6 and solve. What we should see is that down here there was an error converting to a float. I could not change the letter A into a number. That created an error. We're now keeping track of that error so that we can use that inside my if statements. In other words, the only way that I can do all of the calculations right here are if all of my numbers are A-OK, but that is false for this instance because the letter A was not a number. And that allows us now to give out an error message as we start to debug our programs a little bit later on. So that's a good start. We also have this little multiplier here, but now what we're going to do is we're going to start outputting information so that people can not just get the final answers, but can see the steps that are involved in solving the linear system. So the first thing I'm going to do is I'm just going to put inside the label output, I'm going to change the text. Now the text isn't optional, so I'm required to put the question mark to show that. And what I'm going to do is the very first step is I'm just going to rewrite the word solution here. All right, I'm just basically putting that back. I wouldn't have to do this, but we're going to just start tacking a whole bunch of lines together using special type of notation that you guys have seen before. So the label output.text, the next line I'm going to do is I'm going to specify a bunch of information. What I'm going to say for this one, now here's the type of notation I was just talking about. This time I'm going to add on to whatever the text is being displayed right here. So the text right now just says solution. So what I'm going to do is I'm going to jump down to the next line and I'm going to add on a whole bunch of stuff right after the solution. I don't want to lose this. I don't want to overwrite it, otherwise it will disappear, and then all I will be able to see is the very last line that is written, which kind of defeats the purpose of writing out all of the different steps. So this allows me to tack one string onto another. So the first thing I'm going to do is I'm going to put an end line there, and I'm just going to say multiply equation number 2 by, and I'm going to use string interpolation, and I'm going to put a whole bunch of different stuff in here. I'm going to put essentially this statement inside my output to this label right here. So the first thing I'm going to put is my sign multiplier, and I'm going to multiply that by my x1, which is then divided by my x2. That's a string, and if all goes well, which it looks like it didn't, then, oh yeah, I don't need that last parentheses. Okay, so the string I'm creating is multiply equation 2 by the sign multiplier, which is either 1 or -1, and then the x1 coefficient divided by the x2 coefficient. These are going to be outputted as floats, just because it's quite possible that we're going to be dealing with fractions and decimals throughout our program. So let's just test this out. Let's just see what would happen if I just typed in a bunch of information. Press solve linear system, it writes out solution, multiply equation 2 by +1 times 1 divided by -4. In other words, multiply equation 2 by 1 over 4, a quarter, right? 4 divided by a quarter is 1, and then that's going to allow me to continue on with some of the stuff. So that's the proper number. So all is good and well, and we've got a good start to the program. What we're going to do now is we're going to take this guy, the multiplier, and we're going to be changing all of equation 2. So all of the numbers that were inputted at the start, we're now going to be multiplying by that multiplier, whatever it is. And we're going to restore those inside new variables. We don't want to necessarily lose these in case we need them later on as a part of a solution or some output that we want to give the user. But what we do want is we want to make sure that we've got new variables holding on to all of the new information. So I'm going to create some new constants. I'm going to call this new x2. And please remember that what we're doing is we're creating this multiplier to multiply just by the second equation. There are many different techniques, but this is the one that we're choosing. So we're going to manipulate this equation to create opposites in the x, and then the rest will just fall into place. So my new x2 is going to equal multiplier times x1. My new y2 is going to equal my multiplier times y2. And as I'm sure you can probably guess, my new c2 is going to equal multiplier times c1. Sorry, c2, that one should be x2. Sorry, so we're going to be multiplying x2, y2, and c2 by this new number that we just created. What's next? All right, so now what we have is we are going to have opposites. It's going to basically look like this statement right here. We are creating an opposite for our x values so that when I add those, my x value will get eliminated. I will be left with a y value and a number in a very simplistic equation that we can solve for by simply dividing the leading coefficient off of our y value. So we better start writing out some more output just to show the different steps. So the output I'm going to be putting here is going to be, and remember that we want to add on to the previous statement, so I need the plus equals, which will allow me to do that. And I'm going to say end line, so it moves down to the next line. And I'm going to write out equation 1, and I'm going to use, again, string interpolation to say my x1 value, it hasn't changed. It's going to be exactly the same for every single one that we do. And the same is going to go for my y1 and my c1. And just make sure, I think that looks good. And I'm going to just steal this line. I'm going to copy it. I'm going to paste it. Only this time what we're going to do is we're going to build our new equation number 2. So after we do all of this manipulation, after I multiply equation 2 by this new number we created, we are going to get new x1, sorry, I should say x2. This will be new y2, and this will be my new c2. And I'm also going to be outputting to that label on a new line. And what I'll do is I'll just put a bunch of equal signs here. That's probably good enough. Just so that we can see that what we're going to be doing is we're going to be adding these vertically, and this equal sign will be written sort of as a line underneath. Let's just check to see what the heck's going on here. Let's put in some numbers, 1, 2, 3, maybe 2, 2, 4. Let's see what that looks like. So my solution says that I'm going to be multiplying equation 2 by a half. 2 times a half is 1. That will create the opposites here, and as long as I multiply all of these numbers from here by a half. 2 multiplied by a half is 1, 2 multiplied by a half is 1, 4 multiplied by a half is 2, and that builds the second equation here for me. So that looks great. So let's keep moving on. So what comes next? Well, now it's time to add the equations. Once we have the opposite, so the whole purpose of all of this stuff right here was to make sure that my x coefficient, the number attached to x, is opposite each other. Now that I've got that, what I'm going to do is I'm going to add the two equations together. And that means 100% of the time, the x values will get eliminated, which is great. That's the whole purpose of elimination. The next portion, what we're going to be doing is we are going to be creating modifiers. That means that what we're going to be doing is we're going to be creating sort of an addition between these two values so that we can add them together. So my modified 2 is going to be my y1, my original y value, added to the new y value right here. And my new y value is called new y2. And I'm going to do the same thing for my c value, and that's going to be c1 plus new c2. So once the x values are eliminated, I'm going to take this y value and add it to the new y value that we just created. And the same goes for our c values. Those are going to be stored inside constant variables called modified y2 and modified c2. And we should probably output that just to make sure that things look all good. So I'm going to have, what should we put? We should probably put something along the lines of, let's see, okay, modified y2, y is equal to modified c2. All right, so it's going to break down into this equation right here. And what this equation represents is what happens after I add my y's together and my c values together inside one really simplistic statement. The last thing that we need to do then is we need to divide this number by the coefficient out here, and that will actually be my y answer. So we can create that right now. We are going to create another variable, constant, called final answer y, and it is going to be equal to my modified c2 divided by my modified y2. And that's it. So we're trying to find a point of intersection. We just found half the point. The y value of that point will be stored now inside this. And while we're at it, we might as well write that out as a little message. So label output.text, and again, we're just going to be adding equal to, and let's see, we'll just put something along the lines of y equals final answer y. All right, let's actually see if this kind of works. All right, let's try like 2, 1, 3, 1, 2, 3, something like that. Sounds good. So what I need to do to create this opposite right here is I need to multiply this guy by 2, which will create the opposite, and then if I multiply this by 2 and this by 2, we should get right here, this would be 1 plus 2 times 2 is 4, is a total of 5 y's. This would be doubled as well, which would be 6, and 3 is 9, and then 9 divided by 5 is equal to 1.8. So that's actually correct. Maybe not the best numbers to work with, but it does show that it does work with decimals, which can also be represented as fractions. So this value right here is 1.8. That's actually what we're after, which is kind of nice. So the next portion that we're going to be working on is how do I solve for my x value? And just so you know, we've got the hardest part done. Solving for the y value is the hardest piece. The last thing that we need to do is solve for our x value by plugging this number into either one of those two equations. It really doesn't matter which one. Let's choose to place it into our first equation arbitrarily. It really doesn't matter. Okay, so I've got my final answer y being displayed. I'm going to now output to the user, because this app is meant for people to help them solve systems of equations, not just to find the final answer. So what I'll do is I'll give them a little message. I'm going to put 2 end lines in there, and I'm just going to give them some direction. I'm going to say substitute y equals, and then whatever we got for the final answer for y, I'm going to substitute that into equation number 1. And what that will look like is, I'm just going to create a statement. The statement is going to say, I'm just going to essentially write out this statement right here, only I'm going to replace the y value right here with the y value that we just solved for. So let's see, that would say x1 x plus y1. Now this is where we're going to be placing in the final answer y that we just created. So to show that I'm multiplying it, I'm going to put it in parentheses, and then I'm going to use string interpolation to put final answer y in there. Looks a little bit scary with all of the parentheses. And then the last thing I need to do is to put my original C1 value in there. And I'm hoping that I put everything here correctly. And it looks pretty good. All right. So we've got now a statement. We're going to do the calculation that we just stated. We're going to create a new variable called final answer x. That is going to be equal to C1 minus Y1 times the final answer Y, and that's going to be divided by x1. All right, so what am I doing right here? Looks like there's a little error, but we'll get to that in just a second. Or not. Okay, yeah, it was just that my multiplication symbol was attached to the variable, so you need a space in between them. So what I'm trying to solve for right now is my x value. In other words, in an equation, we need to get the x value by itself. And we do that by pulling the y value with its coefficient to the other side of the equation. So I will take my C1, subtract this number y1, which is multiplied by my final answer y, which we've just solved for. So this equation right here essentially does all of that math in just one step. You could quite easily break this down into multiple steps in order to solve. This is just a simplistic way to find our final answer x. If there are any leading coefficients that are stuck here, maybe the number 2, we would then have to divide all of that stuff by 2 to get rid of it attached to the x. That's what this division is right here. And then the final output, we're going to put as our label output dot text plus equals, we're going to create that string starting with an end line, and we are going to say x equals final answer x. All right, that's it. That's the whole program. And I know it's pretty cumbersome. There's a lot going on here. I would not expect you guys to do this on your own. But it does show that you can teach a computer an algorithm that works 100% of the time and then feed that algorithm into some output. And you can also associate that with all of the steps. So let's run it. All right, let's just choose a couple numbers, 2, 1, 4, I don't know, 3, 2, 5. Let's just see what happens when we do this. So the first thing that we're going to be doing is we're going to be multiplying this equation by 2/3. That's what that equation looks like when we multiply it by 2/3. What it does is it allows us to essentially add up the numbers to solve for y. Once we solve for y, we take this number, we substitute it back inside the first equation right here for y, and then we solve for x. And if all goes well, this should be the output that we get. That's basically it. There's one last thing that we talked about before right at the start of the program, and that is what happens if I was to put the letter A or some weird input in there. Okay? Nothing happens right now. It's not trying to solve. It's not trying to do any of this stuff, any of the calculations, because it wouldn't be allowed to do that because the numbers were not A-OK. So what we'll do right now, I just want to show you how to create an alert pop-up. Now, just to let you know, this is not something that I would be able to pull from the top of my head. Prior to making this program, I had to do a little bit of research to say, well, how the heck do you build an alert? And if you just Google, in probably 5 seconds, you'll be able to find a page that will show you how to create an alert inside an iOS app. So what we do is we use the UI alert controller, and we create an instance of that class. Now inside of this class, you'll notice that we have a couple different options here. The one I'm going to be using today is this one right here, where I give it a title. The title I'm going to say is, oops. My message I'm going to be giving out is something along the lines of, you need to enter proper numeric numbers, numeric input. And the preferred style that we're using is called a dot alert, which is an enumeration. Okay, so there's a whole bunch of different pre-built styles. The one that we're going to be after is the UI alert. So that just creates a variable for it. So we're not making the pop-up happen yet. And we're going to add an action to this. And that's the one I'm after right there. And, oops, sorry, I'm going to add an action. And the action that I'm adding is a UI alert action title. All right, so as you can see, there's a lot going on here. I'm just going to minimize. Oops, sorry. I'm just going to get inside. I don't need the interface builder anymore. I don't need the storyboard to show this. So the UI alert action, I'm going to put OK here. The style is going to be a .default, and my handler. Actually, I don't think I need the handler. Don't believe I do. I think I can just close this off and build a closure here. I think that closes then that UI action. Okay, so clearly I don't know this off the top of my head, and I would never expect you to. Most of what you guys will be doing, especially as we get into some of the projects later on in the course, you're not going to know how to do stuff. So you're going to have to do a lot of research online to find examples to pull from and then to manipulate those examples to make them work under your circumstances. And the last thing we have to do is we have to present that view controller and this is the one. And we're going to put in the alert that we just created in terms of its action as well. We're going to say it's animated as true. The completion handler, we don't really need all of this stuff at the end. If you wanted to do something afterwards, that would be what these little braces are for. But for our purposes, we're just going to say if something bad goes wrong, like I put the letter A in there, I now have a little pop-up. None of my calculations get finished here at the bottom. And that is it. Thank you for watching.